In this lesson, I'll turn to more concrete, practical matters as you begin to implement your architectural design decisions. At some point, you have to start writing code, and usually architects kick this process off. When an architect creates the initial projects to implement all the desired layers and writes code to drive one small feature of the functionality of the system all the way through from presentation to persistence, this is called an architectural spike. Driving an architectural spike is an agile programming practice, but I felt it was pertinent here. An architectural spike is a thin slice of the entire application built for the purpose of determining and testing a potential architecture. For example, if you're going to write a bank account system, you might spike it by writing a very simple deposit transaction that goes from the user to the database and back again. All right? So you drive a spike through the architecture to demonstrate your design decisions to other team members in a real, tangible example. You say, okay, now you go off, build this, use my spike as an example where you should delegate each responsibility. Here's the naming and the coding conventions and so on. You can kind of see what I'm doing here, right? So in this lesson, I'm going to talk about the practical aspect of driving an architectural spike through your architecture. And so we're going to talk about a number of different things like splitting layers into projects and how to package things into assemblies. We'll talk about naming projects and designing namespaces, coding conventions and how to enforce them, and then also refactoring at a high level. And so like we learned about in a previous lesson, the entire process begins with some thought about the design. We said that we want to do some design, just not big design up front to the point of absurdity. But we have a design in mind. What layers will we use? How will they interact? What are the big ideas in the workflows, and how do we delegate the responsibilities to the various domain classes in our design? Will we drive the development process starting with the domain? What role will unit testing play? Will it drive the design, or will we come back and add them after we've developed a feature? And so those sorts of things. But once we've thought out the design, we've thought about the layers and the interaction and those sorts of things, we'll want to start creating a solution in Visual Studio and begin adding projects. This means that we have to decide on how we're going to package our application into assemblies. Packaging code into components is not an architectural topic per se. However, it becomes increasingly important early on in the development lifecycle to get the names of things correct and organize classes into the proper components or assemblies for the reasons that I'll discuss in this lesson. Before I do, one quick note. As I said earlier in the series, I was uncomfortable with the term component because I felt that the term refers to packaging rather than the way I understood that the authors of like the Microsoft Application Architecture Guide were using it to denote groupings of functionality in different classes working together for a common purpose. As it turns out, the authors meant this in both of the senses, and I was being maybe a little bit too literal in my understanding of their writing. So go ahead and use the term component. Just be aware of the context and of the two meanings of the term. It could mean packaging. It could also mean just classes working together to fulfill a need. Okay. At any rate, once you create classes in each layer, you're going to need to package these classes together somehow into assemblies at some point. So when I use the term package as a verb, I'm referring to the act of compiling code into one or more assemblies. You create assemblies in .NET by assigning different classes into different projects in Visual Studio, in a Visual Studio solution, and then building those projects with F5 or one of the equivalent menu options. So when I use the term package as a noun, I'm referring to the end result of compilation, a deployable component known in .NET parlance as an assembly. So why you choose to assign a given class to a package is up to you. You might decide to put classes in the same layer, classes in the same layer into the same project. You might choose to subdivide those classes into separate projects based on their roles within a given layer, or group neighborhoods of classes together that have an affinity for each other, that work together typically to accomplish something within the system. In other words, you might choose to keep classes together because they rely on each other to perform a given task in the system, and they can be reused outside of the scope of the specific system that you're building. In that case, you're packaging for reuse. Or you could decide to group classes together into the same project because they represent aspects of the system that are expected to change often. And you want to simplify the distribution of those changes by packaging things together that change often in the same assembly. So in that case, you're packaging for change or ease of deployment. Again, this is not an architectural topic per se because we're talking about the physical and not just the logical like we've been doing up to this point. But the names and the responsibilities of components in the system often reflect the architecture of the system. So from that perspective, I think this is a valid topic to talk about. And because we're now beginning to transition from talking about logical things and moving on into a concrete example in another series that will come after this that will demonstrate a lot of the things that we talked about. So now we need to start applying all of these principles and we'll start thinking about these things. All right, so back to the topic of packaging and where do classes go. For my simple brain, unless I have a compelling reason to do otherwise, I default to splitting up my application into projects, each project representing a single layer in my design. Now, I might refactor that later on once I have a better understanding of how all the pieces of the puzzle fit together, or I have some compelling reason to change how I'm divvying up these classes into projects. But keeping things logically and physically separated at first helps me keep things clean in my own mind. So that's what I default to, and that's what I'll be demonstrating in that next series that follows this one. All right, so now let's move and talk about naming and coding conventions. Since projects are the containers for classes that will be compiled into components, naming those projects is important. Getting the names wrong will add friction and confusion throughout the development process. So what I want to do is just run through some typical project names for the types of components or assemblies that I would expect to see in the system. So assuming that I was working on something called my project, I would probably name things like so. For example, in the for the presentation layer, I might call it the project name myproject.web or myproject.client. If it was a desktop application, I might use myproject.desktop, myproject.ui. I might even choose myproject.presentation or something along those lines. Or I might change if I had multiple presentation applications, presentation layer applications, like a client to be used by end users, and then also I had another project that I intended to be used by administrators. I might split them up like so. So myproject.web.client, myproject.web.admin. All right. In the services layer, I try to keep it pretty simple. I've called it several different things in the past. Now I'm trying to stick with myproject.application services. I've also used application facade, like the name that's used here in the Microsoft Application Architecture Guide. I've seen service layer and things of that nature. Also, if you look at the domain layer, you might expect to see things like myproject.domain or domain model or something along those lines. I've also seen myproject.business layer or myproject.bll. Or if I needed to even split that up further, I might do something like myproject.domain.customers or myproject.domain.orders, something along those lines, to delineate the various aspects. This is customer management, this is order management module, this is myproject.domain.accounting, something along those lines. In the persistence layer, I'd probably call it myproject.persistence or myproject.data. I've seen people call it myproject.data access layer or .dal. Okay. As far as other things like the DTOs or the data transfer objects, enums interfaces, things of that nature, it kind of depends. I might try to bundle some of these up together in something called common, so myproject.common. If I wanted to separate them out, I would just call them what they are. So myproject.contracts, that would hold maybe any interfaces that I had that I needed between 2 different or 3 different layers. Or myproject.dto, if I wanted to just keep that to the classes that would be exchanged between 2 layers. And so then I'd have a reference to that project from the 2 different layers, and I'll demonstrate that. And there's also the naming convention for unit tests. So I would probably choose to add the term unit test after the project name that I'm unit testing. So if I had, for example, a unit test project that I wanted to create so that I could test out the myproject.domain, then I would call it myproject.domain.unittests. So, and I think that's the coding convention that they use, that you see most frequently online. All right, so in addition to designing components by assigning classes to projects based on their role in layers or some other criteria, you have to keep in mind namespaces as well. So by default, your default namespace will be dictated by your project name, but you can change the default namespace in your project's preferences panel. So you right-click on the project, select preferences, and there's the preferences panel, and you can change out what your default namespace is for that project. And you can also use different namespaces and create new ones on the fly in your C# code, so you always have that option. So remember from our C# Fundamental series that namespaces are used to reduce ambiguity between class names that are in the same project. So namespaces should reflect the function or the purpose of a given class. And so you're creating your components. You should be thinking about the namespaces of individual classes, because that will clue developers who might consume the code that you're creating or who are supporting your code in the future which classes they should be using. When you're building components, you're essentially designing an API, especially on the domain layer. Finding a particular class in an API can become challenging if it's not named correctly. So for example, you might have a namespace like myproject.data. So which classes would you expect to see in this namespace? Order, order DTO, or order repository? Well, personally, I would expect to only see order repository in a myproject.data project because order I would expect to just by itself, I would expect that to have something to do with the domain. Order DTO, I would expect that to have something to do with data transfer objects. I would expect that to be in its own layer. So the only one that I think would fit in a project that was named myproject.data would be an order repository class. We said repository is a term that indicates a design pattern for basic CRUD operations for a given entity. So that's why I would expect to see that in a project that was focused on data. So you might talk me into just the term order, but to me, without any additional suffixes, I tend to think of those as domain objects. But at any rate, interestingly, naming and packaging poses a significant challenge for developers. My friend Dave has often said, and I've stolen this one for my own use, naming things is the hardest part of programming. That used to be an overstatement just to make a point, but I was reminded of this whenever I read this book, and I'm going to come back to it a little bit later, Framework Design Guidelines. Christoph Swilina, I think is how you pronounce his name, and Brad Abrams, both of Microsoft, wrote this book. They recounted their own challenges in creating namespaces and names for classes in the .NET Framework class library. They poured hundreds and thousands of hours into testing namespace and class names in the .NET Framework library, asking developers to complete a task and then watching how long it took for them to work through the class library to accomplish that task. They recounted that at times they got it wrong and how they wished they would have changed names and the organization of classes within namespaces. But once you release an API, it's hard to change it. Even a small project, something much smaller than, for example, the .NET Framework class library. And furthermore, they package classes by families of functionality and perceived usefulness instead of the ways that I suggested earlier, packaging them for reuse or packaging them for deployment or redeployment. So that's another way that you can split things out by families of functionality and perceived usefulness, and then only the developers who work on the front end or whatever the case might be would only need to load in those assemblies that apply to them. So that brings me to another topic, coding conventions. What do you name local variables, public properties, private properties, class names? How do you decide about tabbing or indentation levels or white space? Instead of detailing all this in a video, I would recommend three things. The first one, that you and every team member on your project should read this book, the Framework Design Guidelines. It's also available at this URL, and you can just read it online if you like to, but I like having the physical copy myself. you can decide to override some of the suggestions that they make about naming conventions and so forth. And if you do that as a team, so be it. That's great. But at least this book can help solve some arguments about naming and coding convention between developers. Secondly, you can use a tool called StyleCop, which is just a utility that analyzes your code and it points out where it potentially violates the guidelines that are set forth in this book. All right. It's also been incorporated into Team Foundation services so that when you attempt to do a check-in of your code into the source code repository, it'll perform the analysis and only allow a developer to check in the code that abides by these rules. It's a feature known as code analysis check-in policies. Or you can add it into your build process because it comes in both a GUI format and then also a command line format. So it comes with a standard set of rules that coincide with the framework design guidelines, but you can also add more rules if you like, so you can tailor it the way you like to. The key here is that StyleCop analyzes your coding style and it checks for compliance with the framework design guidelines and any other styles that you want to enforce within your organization. And I also think that it's worth pointing out that there's another tool that's built into Visual Studio 2012 Premium and Greater called Code Analysis. And there's a separate tool called FXCop, which is great if you only have Visual Studio 2012 or lower. And it can be downloaded independently, and they perform similar functions even if the types of things that they report back might slightly vary. Basically, these tools, Code Analysis and FXCop, will watch out for future problems in your code. For example, code that may not perform the way that you hope it will. It does cover some of the same ground as StyleCop, like naming and capitalization issues, but it focuses more on things like things that'll degrade performance, things that'll make your assemblies vulnerable to malicious code or malicious users, things that could be maintainability issues or portability issues. It'll detect problems with memory and thread usage and things like that. All right, so I suggested that there were 3 things you could do to improve the quality of your code. First one was framework design guidelines. The second was StyleCop. The third is a third-party tool that I find extremely helpful whenever I'm doing software development. It's called ReSharper. You can also notice it. It's just re and a pound sign like C#, ReSharper. It's by a company called JetBrains. It's an add-in to Visual Studio, and it has many features, not the least of which is to highlight any styling problems with my code as I type, so I don't have to wait to run it through some the StyleCop at the end of development. I can see it right there as I'm typing. And I like it because it also sees what I'm trying to do, and it points out some other things that could be wrong with my code. It says, hey, do you realize what you're trying to do here? It took you 3 lines of code. You could do that in 1 line of code. You want me to do it for you? And then you just hit like Alt-Enter on your keyboard, and it will just go ahead and retype the code, and you can undo that if you don't like it, if you don't like the style. But it's a great learning tool in that way. It's like, I didn't know I could do that. Very cool. Or, I didn't realize that that was a style violation. Okay, I'll try to remember that from now on. So it's a great learning tool whenever you're typing code. It allows you to also to inspect your code. It uses FXCop and their own analysis tools of your code as you type. It's like $150, I think, for the individual license if you just want a single language like C#, and I've gotten a lot of value out of it, so I recommend it and recommend it for a team whenever you're sitting down to do development. It can help keep everybody on the same page. All right, so finally what I want to do in this lesson is talk about refactoring. Admittedly, refactoring is more of a low-level topic than a high-level architectural topic. However, with regards to the high level, I believe that refactoring a design is something that architects will need to do on occasion. If you're not familiar with the term, refactoring is improving the quality of code over time by making small changes to it. You move away from code that smells. In other words, you move away from an implementation that could spell trouble in the future for a more stable, better thought out implementation. This is a common practice whenever developing software. It's even a staple for test-driven development. If you've ever heard the term red-green refactor, it's a 3-step process. First of all, you write code to watch it break, then you write code to watch it work, and then you refactor it to make that code of a higher quality. So taking that mindset of refactoring after you've designed something from a macro perspective, a big picture architectural perspective, it makes sense as well. If there are architectural smells, you need to find ways to refactor the architecture of the application. This could take a number of different forms. For me, it usually has to do with where something should be implemented. Whose responsibility is it to take on this task? Initially, I felt one way about it, but after I drove an architectural spike through the application, I'm tending to think that this is uncomfortable. I see that the design is boxing me into a corner, and it might be resistant to change in the future, so I will spend some time then to refactor it, to decouple, to separate concerns, maybe add a layer of indirection, maybe inject an implementation of something, and so on, in order to make that feel architecturally a little bit more solid going forward. And I believe I said this earlier. I used to think of designing and architecting an application like chiseling a sculpture out of stone. I now see it as massaging and shaping and molding clay into a position in order to create a sculpture. So refactoring is the process of massaging the clay in your application, the code of your application, the design of your application into an increasingly better design without hopefully impacting the features or the amount of time you spend building the application. All right, so to wrap up in this lesson, I talked about driving an architectural spike, a thin slice of the entire application, built for the purpose of determining and testing a potential architecture. This helps architects validate their assumptions and their design, and it helps communicate those design decisions, as well as things like coding style, naming conventions, and the like, to the rest of the development team. We also talked about making packaging choices, as well as naming projects, naming assemblies, designing namespaces. We talked about the tools and the resources that can help you in this regard. And finally, I talked about refactoring a design into shape. All right, so we'll wrap this up in the next lesson. We'll see you there. Thank you.